Hello and welcome to my tutorial on probability. Probability can be defined as a measure of chance or likelihood that an event will occur. It's a measure of chance or likelihood of occurrence of some event. Some of the basic concepts in the subject of probability include random experiment, and a random experiment is an experiment for which the outcome cannot be predicted with certainty. In other words, you cannot predict an outcome of a random experiment in advance. For example, tossing a coin to see what face will show up is a random experiment because one cannot predict its outcome, whether it will be a head or a tail, with certainty. Another concept is that of a sample space, and we're saying that a sample space is a set of all possible outcomes of a random experiment. So if you're having a random experiment, you just list all of the possible outcomes. So that is what forms a sample space. For example, in a random experiment of tossing two coins simultaneously, we have 4 possible outcomes. So the 4 possible outcomes will form a sample space. So that sample space is a list of all the possible outcomes. If you toss one coin, you have 2 possible outcomes. You either have a head or a tail. So a head or a tail is a sample space. Another concept is that of sample points stroke events. So there is a difference between a sample point and a sample space. A sample point is a subset of a sample space. For example, the event that we have a head and a head in the sample space of the whole of that. So that a head and a head is a sample space. A head and a tail is also a sample. A head and a head is a sample point. A head and a tail is also a sample point. A tail and a head is a sample point. A tail and a tail is a sample point. An event comprises of one or more outcomes of an experiment. Let's go ahead and look at types of the probability. The probability that an event will occur can be obtained using 2 approaches. We can begin by the equally likely approach. Here, the probability that an event occurs is simply the number of outcomes in the event divided by the total number of possible outcomes. If we have an event A, for example, say we are having m of the n outcomes, then the probability is m over n. That is what we call the equally likely approach. Tossing one coin has a total of 2 outcomes. The 2 outcomes are a head and a tail. Therefore, the probability that you have a head, 1 over the total possible outcome, which is 2. So 1 over 2. So 1 over 2 is the probability that we will have a head showing up. And the probability that we have a tail showing up is 1 over 2 as well. Moving on, we can talk about relative frequency approach, which is a type of probability. It states that the probability that an event will happen in the proportion of times. Relative frequency approach states that the probability that an event will happen is the proportion of times that we would observe it if we repeated the random experiment a large number of times. So the probability of any event, say A, ranges between 0 and 1, and this one you should note. Probability of an event A ranges between 0 and 1. When the probability of an event A is equal to 0, this implies impossibility. It is impossible for that event to occur. And when the probability of an event A is equal to 1, and that implies certainty. In other words, it must occur. If the probability of an event equals 1, then it must occur. We are certain it will happen. An example of certainty is where the probability that the sun will rise from the east is 1. we are certain that the sun rises in the east. So the probability of a sample space is 1. The probability of a sample space is 1. Let's look at an example of a sample space where we had a head and a tail from the experiment of tossing a single coin. The probability of having a head showing up is 1/2, and the probability of having a tail showing up is 1/2. We know that the probability of a sample space should be the probability of this plus the probability of this. So a half plus a half is 1, and therefore the probability of a sample space is 1. Take note of that as well. Moving on, we can look at further properties on probability. Let's begin by talking about the additive law of probability. Let A and B be two events in a sample space, say S. The probability of the union of A and B for not mutually exclusive events, also known as independent events, is given by this. That is, if we have two events A and B, and these two events are not mutually exclusive events, in other words, they are independent events. Let's define independent events. Independent events are events, or let me say, an independent event is an event whose occurrence does not affect the occurrence of another event. That is, the two events are not mutually exclusive, and therefore the probability of the union of these two events is given by the probability of A plus the probability of B minus the probability of A intersected to B. So if the two events do not have any outcomes in common, meaning they are mutually exclusive events, then the probability of the union of these two events is given by the probability of A plus the probability of B. Events A and B are referred to as mutually exclusive or disjoint events if they do not have any outcomes in common. The other law is that of the law of complements. If A is an event, then the complement of A, which is denoted by A complement, represents the event composed of all outcomes in the sample space S that do not belong to the event A. An event A and its complement are mutually exclusive and jointly contain all the possible outcomes. For instance, the union of A and its complement is equivalent to S, which is the sample space. So the law of complement states that the probability of the union of A and its complement is equivalent to the probability of A plus the probability of A complement. Because these two are mutually exclusive, we just add them like that. And this sum is actually equivalent to the probability of that sample space, because that sample space is made up of A complement and A. And the probability of a sample space is equivalent to 1. This implies that the probability of A is equivalent to 1 minus the probability of A complement. That is worth to take note of as well. Moving on to the multiplicative law of probability. This law states that if two or more events are independent, then the probability of two or more events is given by the product of their individual probabilities. If A and B are independent events, then the probability of the intersection between A and B is given by the probability of A multiplied by the probability of B. That is the multiplicative law of probability. To define what independent events, I have already done that. Two events are said to be independent if the occurrence or non-occurrence of one event does not influence the occurrence or non-occurrence of the other event. An example of a worked out is actually a worked out example. Let the probability of an event A be 0.4 and the probability of an event A union B to be 0.7. So find the probability of B if A and B are independent events. If A and B are independent events, then the two events A and B do not have any outcomes in common, and therefore we use the initial additive law, where we say that the probability of A union B is equivalent to the probability of A plus the probability of B minus the probability of their intersection. Independent means there is an intersection between the two events, and therefore adding these two, we have to subtract their intersection to avoid double counting. This means the probability of A plus the probability of B minus the probability of A intersection to B is the same as the probability of A multiplied by the probability of B. And this has been given as a 0.7. Probability of A is 0.4 plus the probability of B minus 0.4 multiplied by the probability of B. 0.7, let this one move on the left hand side so that you have 0.7 minus 0.4 is equivalent to the probability of B minus 0.4, the probability of B. Here we have 0.3 being equivalent to 1 minus 0.4 is 0.6. So we have 0.6 multiplied by the probability of B. So that to get the probability of B, we divide both sides by 0.6, both sides by 0.6. That we get the probability of B as 0.5. That is if the two events are independent. If the two events are mutually exclusive, that is if they are not, independent, then we do not include the intersection part of it. So we just say that the probability of the union of A and B is equivalent to the probability of A plus the probability of B. This is equivalent to 0.7. The probability of A was 0.4, and the probability of B should be now 0.7 minus 0.4. This one comes on this other side, so that you're left with 0.3. So the probability of B is equivalent to 0.3. Thanks for watching. This was just an introduction to probability.